Next is a book I really like really like. It's Peter Mann's Lagrangian and Hamiltonian dynamics. So, as the book says, it covers Lagrangian and Hamiltonian dynamics, as well as related formalisms. So the first part is on Newtonian mechanics, very briefly. Then we come to Lagrangian mechanics, stationary action principle, constraint Lagrangian mechanics. We go all the way to virtual work, to the Jacobi energy equation, and so on. Next, we come to canonical mechanics, where we do things like Hamiltonian phase space, even Ruthian mechanics. We do Poisson brackets, canonical and gauge transformations. Finally, we end up with Hamiltonian Jacobi theory, the Liouville theorem and classical statistical mechanics, all the way to Kamm theory. And then we have classical field theory, Lagrangian and Hamiltonian field theory, classical electrodynamics, and Noether's theorems of field and classical path integrals. There's also parts on preliminary mathematics and advanced mathematics, as well as many exam-style questions. I think this book is really good in terms of theory. It explains the theory really well. There's very beautiful illustrations. The problem with the book is a bit that there's a lack of exercises. Like the exercises are not that plentiful. There are some exercises, but really not that much, to be honest. Even though I think it's a really good advanced mechanics book. Probably a book that you can fit well in after a book like Taylor, where you go in this kind of thing more in depth. Even a book like, even if you know Newtonian mechanics already, you can probably do this book. So this might be a book to replace Lemmas, for example, and it's in a sense even better than Lemmas. The problem is that Lemmas has much more exercises and much more, varied content. So yeah, I really like this book, and I would recommend this book to basically everyone who is interested in physics and mechanics. The next book, we're going to do a lot of statistics today. So the next book is by Kleinbaum and Klein, Logistic Regression, a self-learning text. So this book is completely a regression book, logistic regression book. It's very comprehensive on logistic regression. So it has the odds ratio, it has maximum likelihood techniques. It has stuff like modeling strategy, confounding, goodness of fits, binary logistic regression, matched data, Paul Thomas logistic regression, GEE examples. So it's a very comprehensive book. The book is 600 pages of regression, and it does a lot of practice and a lot of practice examples. I'm not sure the book is really for me. I think while I think that a book can definitely be useful, even if it is not theoretical and mathematical, this book was maybe a little too little mathematical for me. And there was not enough real theory. There was just basically telling you how to do logistic regression instead of why it really works. Our next book is Introduction to the Theory of Statistics by Moot, Graybill, and Booth. So it is a book on statistics. It starts with probability theory. It goes on to all kind of special families like discrete and continuous distribution, joint and conditional distributions, random variables, sampling, parametric point distributions, parametric interval estimation, test of hypotheses, and then it goes on to linear models, on parametric models, and that's basically it. So I think this is a book which could very well replace Casella and Berger, and I think it's very good at that because I think Casella and Berger is kind of really boring. Well, this book I think is a very interesting book. It does things in a way that I like. It's not the most well-known book, but I think it's pretty neat. Of course, in terms of probability, a book like Blitzstein is better, but in terms of statistics, this might be exactly what you want. It approaches it from a pretty mathematical, nice point of view, but not overly mathematical, so no measure theory is done. So yeah, definitely a book that I would recommend for statistics. Then we come to Lehman, Non-Parametrics, statistical methods based on ranks. So it's a book on non-parametric statistics. So it has the rank tests, it has comparing two treatments in a population model, it has blocked comparison for two treatments, paired comparison, the comparison of more than two treatments, randomized complete blocks, test of randomness and independence, and then it already has the appendix. So it's fairly, like Lehman's style is obviously a very mathematical style, a very deep theoretical style. So it's not a book that everyone will appreciate, but I definitely do like his style, even though it's not introductory at all. So yeah, good book, but I haven't read too much in it. Then we have Christensen's Analysis of Variance, Design and Regression, Linear Modeling for Unbalanced Data. So this is basically a book on ANOVA and ANOVA techniques. It has one sample, it has general statistical inference, it has two samples, contingency tables, simple linear regression, model checking, lack of fits, multiple regression, diagnostics and variable selection. Then goes on to multiple regression matrix formulation, one-way ANOVA, multiple comparison models, two-way ANOVA, ACOVA and interactions, multi-factor structures, basic experimental designs, factorial treatment, dependent data, logistic regression, log linear models, exponential and gamma regression, nonlinear regression. So yeah, a book basically on ANOVA structures. I think this is a pretty good book. I haven't read too much in it, but the book definitely appealed to me. It gives nice examples. Doesn't really give derivations or anything. So it's not a book that would personally be for me, but it tells you basically how to do ANOVA and how to approach it from practical point of view, which of course is crucial in statistics. So yeah. The next book is Modeling Survival Data in Medical Research by David Collette. So what does it cover? It has survival analysis, non-parametric procedures. It has the Cox regression model. It has model checking. It has parametric proportional hazards model. Then it has accelerated failure time. It has time-dependent variables. It has interval-censored survival data, frailty models, non-proportional hazards, competing risks, multiple events in event history modeling, dependent censoring, sample size requirements for survival study. So yeah, it's a book on how to do survival analysis and exactly what kind of models exist and how to approach them. So if you're survival analysis basically deals with data that decay in time. For example, patients die. And for example, machines in a factory, they break down. And this would basically deal with this kind of data. Yeah, I like this book. It's a neat book on a topic. Again, not too mathematical. It basically teaches you how to approach these things, how to model these questions, what the modeling really means. Next, a book that Chegg really likes, Statistical Rethinking, a Bayesian course with examples in R and STAN by McElreath. So definitely one of the better books on Bayesian modeling, but it's also a very niche book. It has associated lectures online, so it has pretty nice chapter titles already. The Golem of Prague, Small Worlds and Large Worlds, Multivariate Linear Models, Interactions, Overfitting, Markov Chain Monte Carlo, Big Entropy, Monsters and Mixtures, and so on. A very, very good book in how to do Bayesian analysis. Very recommended for Bayesian analysis. You definitely want a more advanced book on Bayesian modeling after, but as a starter, this is really beautiful. It teaches you how to think of Bayesian analysis, and it teaches you how to program Bayesian analysis in R. So I like this book a lot. It's an extremely good book. Yeah, if you're into Bayesian, you want to get into Bayesian, this is definitely a book I would recommend. Next, we have a book on Advanced R by Wickham. So it's assumed you know R pretty well already, and it basically goes into the very details of the R language and how you can improve basically how you think of R, and basically some tricks to deal with it and why things are the way they are. Even though I did read this book completely, I was working with a study group at work, and I did read this book completely. I'm not sure I remember too much of it. You probably need to reread it again. But I did get some tricks of it, of course. But yeah, it's not too memorable. Then we have a book on data clustering, Algorithms and Applications by Agarwal and Reddy. So yeah, we have cluster analysis, all kinds of cluster analysis of text, data, and otherwise. Feature selection. You have probabilistic models of clustering, survey of partitional and hierarchical clustering algorithms, grid-based clustering, non-negative matrix factorization of clustering, spectral clustering, clustering high-dimensional data, survey of stream clustering, big data clusterings, clustering categorical data, document clustering. Then we come to clustering of multimedia data, time series data clustering. You have clustering biological data. What else? You have network clustering. We have a survey of uncertain data clustering algorithms, concepts of visual and interactive clustering, semi-supervised clustering, alternative clustering analysis, cluster ensembles, clustering validation measures, educational and software resources for data clustering. So yeah, it's basically a very comprehensive work on clustering. I did not read this book. I used it somehow in references. It's a rather advanced book. It's basically a book for PhDs who want to do their research in this. And it has no derivations at all. It just has basically the models and the explanations. I would not buy this book again unless you're extremely interested in clustering, which I'm not. But yeah, this book is probably one of the best on clustering.